early in the afternoon, but the council wanted us to run this session like it was a late-night television show. So they brought out a coffee table, and they sat us around here, and we're going to try
a couple of clowns.
Yeah. So we're going to try to keep this as informal as possible, and we're going to try to have as much audience participation as possible. Now, the name of this session is How High Can We Go, and Why Should We? And the second part might be the maybe the most interesting and controversial discussion. But before we go any further, I'd like to introduce our panel in the order that they will be speaking. No long introductions. Everybody here is very prominent in their field. Their firms are also extremely prominent in their field. After I say a few things, following me will be Vincent Say. He's the managing director of Parsons Brigerhoff out of Hong Kong. And he will be addressing the mechanical and electrical and related areas to MEP. Then we have Raphael Vignoli. He's the principal of Raphael Vignoli Architecture, and he will be addressing architectural issues. And last, but certainly not least, Tony Long, who's president of Global Asset Development at CBRE, and he'll be discussing the development and the economic issues. And they might also be discussing things I didn't even think about yet. So we're going to keep it very, very informal. What we're going to do, each of the speakers will give about a 2-minute quick presentation. We have about 5 slides each, just to stimulate the thinking. Then we'll have a little panel discussion up here for maybe another 10, 15 minutes the most. And then we'd like to open it up to you, the audience, and encourage as much interaction and comments as you would desire. So please think about what you may want to say. If I could just have that pointer. There we go. I need both of these things here. We got to. Oh. So I'm going to start with some of the structural issues. And then our panel will have a more general discussion talking about the limitations, if any, on height, and should we even strive to achieve them. So first I want to just give some of the structural issues and some of the things that we talk about, and some of the things that other people are talking about. So concerning how high we could go, concerning how well this thing works, there we go. If you look at the Space Administration in the United States, when you ask them how high we can go, they think in terms of a space elevator, which is basically a satellite, which is the center of gravity of this system, in orbit with a skyhook balanced by a counterweight. And they have designs that go from 4,000 kilometers up to 100,000 kilometers. Then they come down to earth a little bit and they talk about the limits of carbon epoxy composites used as a column, a tapered column. Okay? And they give us another limitation that just holding up its own weight, okay, you can get up to 114 kilometers. Of course, there's no floors on that, and there's no bracing. Just giving us some idea of some limitations that are way out there. But we have to come down to earth, and if we look at the materials we mostly use, such as steel and concrete, the same column compared to the epoxy column for steel and concrete would get us to these heights. But if we decide to make it a building and put a typical amount of floors in there, we're going to be at heights somewhere between 3,200 meters and 1,100 meters, just the tapered column itself. But that's not very, very high. And again, these are approximations depending on the strength of the materials. Once you start putting lateral loads in, especially wind, these numbers get reduced by 30 to 50%, about 30 for concrete, 50% for steel. So that doesn't seem too high. We already have buildings going up that are going to be 1,000 meters with lateral loads. And that comes from what we've been doing for many years, is the basic approach of, for example, of tapering the building. As you can see, it's been done for many years, and it's being done on this beautiful building by SOM right now, which is the tallest building in the world. But what this tapering does, it distributes the loads at the bottom, number one, that's obvious, and it minimizes the wind because of the shape. But also, the shape encourages or reduces the effect of the vortex shedding around the building. And that can also be reduced by other methods, such as twisting a building, like on Shanghai Tower, or putting different rough corners to distribute more or less the vortex shedding. So by doing that, you get rid of the possibility of these vortexes acting coherently up the height of the building and getting close to a resonance with the building. And you can significantly reduce the effects of the wind load. And this is something that's being done more and more. If you look across through your window at Shanghai Tower, it reduced the wind effects by about 25%, and it actually reduces the overturning moment from the crosswind effects in the order of 60%, just by this integration of engineering and architecture. And I would say that our biggest tool for going taller and taller is something we've been using for years, which is the integration, the proper integration of engineering and architecture. Whether it's from Gaudi's rough tapered spires to the jagged circular shape that helped diffuse vortex shedding on Petronas Towers, to the total integration on Kingdom Tower of the architectural walls, the structural walls, actually not only being designed to reduce vortex shedding, but being designed in such a way that they become the boundaries of the architectural space, giving you a total efficient integration. So I think that's one of the most important things that will get us higher and higher. But there's many other things we have to consider. The slenderness of a building. There's a big difference between a very tall, wide building and a very tall, slender building. The dynamics start getting very, very interesting. And there are many other things that we have to consider, some listed here, in the non-structural elements. So to put structure out of the way, okay, there's no problem going to a mile-high building today, maybe even higher. And did I get there? So there's no problem getting that high. But I think we have to answer this question with some humility, okay? Because technology is changing so rapidly that what we might consider today as something that's futuristic was science fictions many years ago. And in the future, what we think is futuristic could be just considered standard technology. So we have to be careful. So with that, I'd like to turn our conversation to some of the other elements in the MEP, architectural, and the economic areas, and turn it over right now to Vincent Tsay, who's going to talk about some of his concerns. Right. Unless you want to go backwards.
Can I borrow your thinking? When we have a discussion about how high can we go, and then I just want to add a friendly amendment with Richard, how high we can live, because whether we should count the pinnacle or not. Sometimes the pinnacle could be 300 meters, right? So when I try to use the council picture, the top 20 building by 2020, actually we found today the highest floor we can live is all below 600 meters, just like all this green area. I don't know the Kingdom Tower, maybe 600 to 700. But the thing is, in order to live at that height, can we live further higher? So there are three fundamental MEP content which affect this content. The first element is the elevators. I think a lot of elevator experts in the section, apparently, right now in Burj Dubai, it was the tallest building on earth, but at that time, the highest speed elevator 10 meters per second. But today, it can go to 20 meters per second. And already there are few buildings with 18 meters per second under design and construction right now. So the limiting factor for elevator is the speed and also the comfort. How many seconds you can tolerate and ride in a car, you can no window, etc. Another is how many times you can transfer. So the observation is maximum transfer twice. You won't be happy with transfer more than 3 times. So in other words, with transfer, you can get up to, you can live even 1,000 meters. But I think if the structural engineer can do it, you can live anywhere, right? And then the second item is air conditioning. Because when you're so high, it cannot be natural ventilation. Because it's windy, it's cold, warm, a lot of daylight, a lot of sunshine, you need air conditioning. In the Burj Dubai, it's so tall, by using the pump the chill water, the cool water cool the tower with 2 zones. But this is the maximum. When you divide the 2 more zones, the water will become warmer and warmer, the chiller will more inefficient. But now the trend is that more people put the chiller in the roof higher. Some more building put a chiller in the middle building, or even a few more chiller plants. When you put chiller plant, that means you can put higher more zone. That means your building could be 1,000 meters, but depending how you stack the chiller and zoning. But now, when you put the chiller on top, the fundamental, how you deliver the chiller, how you maintain them. This is the limit. And the power and data, which is another last element. And the Burj Dubai, you see they have all the transformer, a lot of zone, and also the big elevator for 4.5 tons to deliver a transformer. Right now, if you're in the future building, if you don't have a big elevator to transform your elevator, your building is dead. Because transformer, you need to replace maybe a certain duration of a year. And one thing interesting, in tall building, you cannot open your mobile phone. You cannot collect data. Because when it's so high, you cannot receive any data from outside. So communication is fundamental. And then the last slide, which few people talking about it. If you're a professional, you're a consultant, you're a developer, put focus on the sustainability. We talk about green building, but the thing is, one interesting when we look at the whole life cycle of tall building in the world, so far, there's no tall building has been demolished so far in the whole world. Let's look at the Empire State. Today, it's 83 years old. It's still collecting a lot of rent, and still very high rental in New York. I'm absolutely sure by in its 100-year birthday, it's still collecting a lot of cash. But when the Empire State design, no air conditioning, no data, no sprinkler, but today you get everything. And how many times they cannot collect cash whenever they renovate? That means the tall building life cycle will be 100 years, but MEP system cannot. Give you one good example, the Hong Kong Bank, designed 30 years ago. This is the most expensive building in the world and the highest technology in the world. But today, it's totally obsolete. Today, the whole building, the power not enough, data not enough, air conditioning not enough, fresh air not enough. The whole building is totally retrofit. So in other words, we are professional, we know the building advance. Can we design this building continuing collecting cash every day, but your building can be continually retrofitting, changing? In other words, if your MEP system could not change, your building is no longer sustainable. Thanks.
Thank you very much, Vincent. Raphael, let's have your
Should I
initial
do
thoughts.
this, press this?
Yeah, this one.
The
Is
blue
this
one.
working?
It's working.
It works while I cough, but
Yeah.
I think that both Richard and Vincent and later Tony would explain one of the dilemmas of this question, which is that whatever was not possible, it is possible today. So if one carries that notion further, the idea that technology will continue to evolve, I mean, is for certain more than just a possibility. So I think Vincent clearly showed that whatever didn't happen in the Empire State Building is happening now because it's retrofitted. I'm sure the Hong Kong and Shanghai bank will also be retrofitted at even more expense than the construction. But the question really is really why are you guys collectively trying to go high? And I think that with one caveat in Vincent's presentation, the Twin Towers were demolished. And the Twin Towers were demolished and were always subsidized at the same time. And the construction that comes about now and is under construction will also be subsidized, which brings another dimension to the problem, which is essentially the financial reliability of the business proposition of repeating endlessly the same footprint at a greater cost. So I think the motivation, the fundamental motivation in this is essentially one that perhaps would bring us back to thinking as to whether the intent and the will to achieve height is really connected to an economic cycle, and that essentially what we historically have is the proof that the best buildings, at least in my book, both aesthetically and functionally, are buildings that are not buildings, are structures that are basically representing a need for iconicity, a symbolic function, which I think is completely legitimate and totally present today. If you really look back to this type of structures, they themselves have a level of pleasant design plus a very limited environmental impact, fundamentally because there are platforms to either see or to really experience a view that otherwise is only preview to the CEOs of the very important buildings that companies that are capable of financing. I'm back into this picture just to bring up another controversial subject, which is the same. While the Twin Towers were subsidized for the life of its whole history, and while the new building will always be subsidized, probably one could actually think of structures that are high just simply because they reconstruct the skyline and they provide a platform for public functions to occur in ways that have not been yet exercised in urban design terms. That is an urban and social program that is distributed vertically.
Thank you, Raphael. So, Tony, you've been listening to an architect, two consultants. You represent the real estate industry. What do you think about all of this?
Well, it is interesting to think about this question in light of the role that CBRE plays, in particular the role that I play at CBRE, in that we take care of the occupants once they've moved into these large buildings. And over the globe, we manage about 3 billion square feet for investors in real estate. And so we have an awful lot of data. And the first couple of pieces of data that I want to show you really paint a picture for this correlation between, if a building is taller, is it necessarily more economically viable? So I just took a look at two collections of data, the top 10 markets in terms of occupancy costs, and then the top 10 markets in rental rate increase. And so you can see that this is a correlation to the index of a US dollar, $248 per square foot per annum, and then it goes all the way down the line through London. And you'll see here a collection of Hong Kong, Beijing Financial District, Hong Kong, Kowloon, New Delhi, and then also Tokyo and London sprinkled in. But you can see that the majority of these markets represent markets that have super tall buildings in their stock. It's really, the outliers here are really London and Tokyo, and maybe to some extent New Delhi, but London and Tokyo are the markets that probably on average have buildings that are lower than the rest of this field here. Now, when we go to rental rate increases, this represents the percentage change year over year from 11 to 12 to show a year-on-year increase in rental. And again, this proves out the point that there's more increase in the markets that have super tall buildings than there are in markets that do not. Again, we see markets like Beijing, Guangzhou. San Francisco is in there because of a supply-demand increase in the high technology area. But then across the rest of the field, you see a representation of the taller buildings making the top 10 list. In addition to this, Richard, we did a regression on the height of the building with the amount of rents in Hong Kong, London, and in New York City. And we found a direct correlation. So the numbers regress on those two planes. We just took two data fields. And the scatter plots really do form a nice upward slope that shows that there is a correlation to higher rents and the tallness of the building. But it also showed that there's a point in time and space out there that a building, it loses some of that appeal to the market. So there is an upward limit from a market standpoint in how tall a building can go. And I think some of those reasons are borne out by, what is a tenant looking for? An occupier is really looking for these things, and this is gleaned from some research that we've done through Kingsley Associates and then through our own occupancy practice. But tenants are really looking for location, prestige, life safety, and that fourth one there, view. At some point above, say, 1,000 meters, the view gets to be pretty close to the same. And in some cases, it's actually not as good of a view, the higher up you go, than it is when you can actually see the streetscape and you can see the activities of things going on. And so, Vincent mentioned the workspace technology. You get to some point up in the, just south of the troposphere, technology doesn't work. And so access to amenities. And again, the last thing, it gets to be so expensive the higher you go. You lose the tenant because of a lack of compelling economics. At the end of the day, the tenant is looking for a good deal. They're looking for a space that'll fit their budget, even though they'd love to have their name on the top of any of these buildings that we're talking about here. Now, if you're an investor, the people that are building these buildings, what are you looking for? It's pretty obvious. You're looking for a return on your investment. You're looking for risk mitigation. You're looking for a market to sell this building into. And again, the bigger you build your project, the less liquid the market is. If it's a $4 billion sale, there aren't many of those that happen every year. But if it's less than $1 billion, there's much more of those that go on in a given year. And you're looking to be able to provide operational efficiency and high customer service. So as an investor, these are the things that you're really looking for, which is really the supply side of this how high you can go argument. The last thing is, as I talk about this innovation that's going on in technology, and Vincent, you touched on this. In the lift world, I do think there is an upper limit to how many times you can transfer. Yeah, it's 2 or 3 maybe maximum. But the lifts that are going in the building across the street, Shanghai Tower, are really astounding. These lifts go 59 feet per second. And the very first lifts that were installed in an by Otis elevators in 1857 went 40 feet per minute. This means that if you're on the ground floor to get to the 121st floor of this building, you can get there in a little less than a minute. So astounding technological changes. It also means, though, that you're losing about 4% of the atmospheric pressure for every 1,000 feet that you go up in the building. And so your ears definitely are going to pop, and there's going to be definitely less oxygen at the top of this lift ride than when you started. So there is a need for these elevator cabs to be engineered in such a way that there are atmospheric pressure fans, and also just, you know, the vibration of these cabs. It needs to be a comfortable ride. And so all of these things are innovations that are being deployed at Shanghai Tower. So I think that opens up the group for maybe some debate.
Well, thank you, Tony. Thank all of you for your initial comments. But sticking on with the elevators for a moment, we've experienced that there's another aspect of elevator technology that has to be looked at, and it has to do with the integration of the elevator performance and the structural performance. That on very, very tall and very slender buildings, okay, which have very high periods, maybe above 12 and getting into the 15 range and up, there's a concern about the actual vibrations of the elevator cables and the trajectory of the elevator itself because of the final sway of the building. Vincent, have you experienced any of the technology in that area? Want to comment on that?
Well, in fact, for all buildings taller than 400 meters, now the elevator contractor, they're very knowledgeable. They have a sway detector in the top of the machine room. So when the sway is over a certain millimeter, and then they either reduce the speed of the car or park the car at different locations such that the roof will not vibrate to the resonance. Make sure they don't resonate. So far, the technology is manageable.
Yeah, in fact, I think on Shanghai Tower, the actual connections to the elevator have this system that senses any vibration and tends to correct that.
Yeah.
Right? Another point that came out of this discussion, which I think both Tony and Raphael touched on, was the prestige value or the esteem value. Raphael, you talked about it in the sense of that maybe could be there without it actually being a building, or maybe it's part building and part spire.
Yeah, I think the council has this very telling also dilemma relative to the occupied floor or the not occupied floor. I mean, when you look at the most recent buildings and buildings that are in the drawing boards, are hard to imagine that in at least 1/3 of the total height of the building there is something productive up above, right? But more importantly, I was going to ask you if the definition of what the investor is looking for is really applicable worldwide. It is, you know, if you know the Shard in London,
sure,
it's empty and it will be empty for a while. And it basically is there because of the financial power of Qatar, and you know, we all enjoy it because it's a fantastically beautiful building. But I doubt whether it is a sound financial proposition. Even in regions like this, in a city like Shanghai, you know, the reality of a free market condition is also murky. I mean, you know, it's all essentially, it's like the deal on the wall, on the One World Trade Center. I mean, you know, if I think I have an office in the ground floor of a shabby place in Manhattan, I think I pay I pay more than Condé Nast in the, who's renting 1.5 million square feet in the World Trade Center. So I think there is a real dislocation between the idea of purpose of these structures and its justification. The fact that the buildings are tall at a certain point from a marketing point of view have to be an absolute nightmare because you're competing against yourself. Right?
Yeah, I think the principle that I would stand on is that the investment and market condition will drive how high you can go in a building, but you have to expand your investment horizon, not just look at the asset itself. Take the Eiffel Tower, for example. I think the Eiffel Tower has produced billions and billions of dollars worth of economic benefit for the neighborhoods around that building, but not necessarily for the owner of the Eiffel Tower and the rents that it's collected. Because from my estimation, they collect rents on visitors that go there and also from the restaurant Jules Verne that's there, and understand they pay high rents, but it's only...
That's an interesting phenomenon too, because, I don't know if you recall, but Eiffel built this tower as a developer, and he made a profit and had signed a contract with the city of Paris to disassemble the tower and build it somewhere else, and has become friends, right?
Right.
And probably, I don't know how you measure that level of return, but I can assure you that if you take it out, you may get an important reaction, I presume.
Well, in value engineering, classic value engineering, they have a term that's called esteem value, okay? And
What?
Esteem.
I hate value engineering. Okay. I don't know who invented that word. But
Most of the architects I work
it's not
with hate
that.
value
It's just that if you
engineering.
do good architecture, you're doing good engineering.
That's right.
So-
But they still define the term.
I know. I mean, what I'm asking you is this. You cannot value engineer the Eiffel Tower, and because, it's essentially nothing other than an aesthetical solution for a structural diagram. Absolutely brilliant, lighter than the weight of the air that encompasses, and a phenomenal experience for people that are not necessarily going there to pay for rent or,
No, you can't value engineer, but I think the term of prestige or value, esteem value, still applies, and in some areas, sometimes the government is involved in helping with a building, and it's being done. Isn't it being done sometimes because they feel, it will put that area on the map, it will increase commerce, it will increase tourism, or would you comment that on? I'll ask you this, Raphael. Would you comment on from an architectural point of view, the client ego is involved also.
Yeah, but that's a failure of accounting, right? Because if in the accounting, and there are very interesting new theories about that too, nobody has accounted for pleasure, right? Mm-hmm. Where is that column in the ledger, right? And most of everything we do is driven by that, right? Including the $125 a foot that people pay in London, right? So the problem is that I think that if you look at it from a market-driven perspective, these structures have a limit, which need not to be the technological limit. There is a need in the last two of the tallest buildings. I mean, the architect is sitting down there. How are you? Good to see you. Congratulations. They're absolutely phenomenal structures, brilliant design, but nobody really, I mean, does the king actually pull up a pencil and makes a calculation as to whether his return on investment works? So that's what I think is important, is that you have to disengage that, find a way through which I'm working on a tower in a place that probably none of you know, Quito, Ecuador, which is 1,200 meters, right in the middle of the point in which the French first defined the zero parallel. And it's a relatively inexpensive cable structure. The whole thing cost $380 million, which for Ecuador is an absolute fortune. But it is probably what the base of the building next door, forget the atriums, cost. And it, you know, we're going to make a building taller than him. It's just that it's not a building. And I think that's an interesting thing. I mean, you know, that thing is 100% pure pride. It's 100% pure sort of the will for being noticed. And I think that's a distinction, actually, quite frankly, that the council ought to adopt. So at least you don't have to define whether it's the occupied floor or the top of the spire. It's whatever looks good. And I think looking good is very important.
Well, I'm going to ask one more question of the panel, and then we'll open it up to audience participation. And whoever wants to comment on this. Do you feel there are sociological limits where people just may not really want to live that high or work that high?
I would, maybe with an oxygen tank or something. But I think you find a market for almost anything. I mean, this building we're doing in New York is not, in number of floors, it's not very tall, but it's taller than the World Trade Center, and it's it's pre-sold. So ambition is unfathomable. And if one day, I mean, look at this, look at the fashion system. They sell you these things that cost probably $3.50 for something like $3,000. I mean, margins are crazy. It's just all a marketing operation. Yeah. But I think that in urban design terms, when you look at one or two buildings, for instance, of the quality of the Burj, it is a phenomenal sculptural event. Mm-hmm. And, when you're landing, you're afraid that probably the pilot needs to be aware that the thing is there. But it's a fantastic thing to watch. So I think that, I hope that there will be, and I'm sure there will be, an enormous amount of technological development to make possible this will for height that seems to be kind of unstoppable. I was totally struck by your first image, because just to have something counterweighted from below that it is, 114 kilometers? What's wrong with that?
Nothing at all.
The only thing wrong with that is that probably you won't see it.
Yeah.
You see, this is the whole thing, that these are fundamentally sculptural objects, and they ought not to be called buildings or used as such, up to a certain point.
So I hope we're not suggesting changing the name of the council to the Council on Tall Structures in Urban Habitat.
What's wrong with that?
What's wrong with that?
I have a comment.
Vincent, yes, please.
I have a comment on your question. In fact, it's a real answer from a CEO from a very big bank in the Hong Kong ICC. That bank owned the 88th floor and the 99th floor, the top 13th floor. And then I started saying, which office you want to put? I want to put it just one floor below the sky deck. I don't want the top floor. Because when you're at 88th floor, when you look out from the 99th, the same. But in my room in 88th floor, I can take elevator much easier. So when it's that height, the difference is very little.
Vincent, if I offer you the 99th floor for 50% of the rent...
In fact, all the junior staff had to put at the highest floor. All the senior staff is the sky deck floor.
There you go.
Very clever. Each to their own, right?
Yeah.
But there are limitations that come down to people's own preferences. With that, I'd like to open it up to questions and comments if you like. There's a lot of functions where they don't take comments, but
It's
we
good
have
because we
questions
don't
and
see
comments.
anything from here.
So, gentleman over here? Yeah, is there somebody with microphones here? Someone's supposed to be here with microphones. Hello? Here we go. This young lady's bringing you a microphone. And please, when you ask your question, please introduce yourself and your affiliation. This way everybody knows the point of view you're coming from.
University of Queensland. One thing that surprised me of first the composition of the panel and the discussion is that there was absolutely no discussion on issues associated to evacuation. Rafael Vignoli alluded several times to the World Trade Center, and we know perfectly well the risks and the problems that a fire can have in a tall building. And I think right now we have a paradigm that implies in the event of a fire we have to evacuate the building. Mm-hmm. And if we maintain that paradigm, it's obvious that there's going to be a limit of how high we can go. Mm-hmm. So, and that obviously affects the structural side, the people side, the architecture, every single aspect of it. And I would like to know if you think that basically if we really want to go much taller, or actually if we have to accept how tall we are, if we have to change completely that paradigm and actually start thinking of designing buildings that are not supposed to be evacuated in the case of a fire.
That's an excellent point, Jose. Do you want to handle that, Vincent?
You like to start first?
I'll start first. Okay, it was interesting. After the very tragic collapse of the World Trade Center, in our office, we had people coming in trying to show us evacuation systems going down the side of a building and special scientific-looking tubes and things of that nature. But I think already, as I understand it, and it's not my specialty, but as I understand it, in certain areas, buildings are built not to be evacuated. They're built with floors, every 16 or 17 floors that are considered safe areas, okay? And evacuation is like the last thing. So I think it varies from area to area. But personally, I think it's a very excellent point that we should be spending more time on. Vincent?
Yeah, and I think you have one of the slides, you put the total structure, if it's not a pier, but with floor, it can go up to technically, structurally, can be up to about 1,100 meters, something like that, right? But what we saw today, even from Asian Kingdom Tower, although it's 1,000 meters tall, but actually the tallest you can live is about 600, 700. So if you want to live another few hundred more, technically and structurally, not a problem. MEP-wise, elevator today, you can elevate, put another few hundred meters. As I said, what is limit to go higher? Your maximum transfer twice. You don't want to transfer 3 times, all right? And then also you have a limit in your car, and also a limit in the speed of the car, although the speed of the car can go up to 20 meters per second. But in the down peak, it can be 10 meters, otherwise your ear is a problem. So there's some limitation there. So 1,000, which is I think the workable range for elevator. And then for air conditioning, when you zone the building, you put 2 zone, 3 zone. It just, actually the tall building is not complicated, it just divide in the zone, just like water tank. In the water tank, they divide the building in many, many zones. So it just like put the building on top of each other. The most important today is reliability. And then the maintainability, how you maintain those stuff. Say, as we said, the Empire State Building, how many times we retrofit? Every time we retrofit, they move the tenant up. And then can we do it much smarter today? So what today, if you're a developer, you should not squeeze your consultant, MEP space. Otherwise, I got a tenant, I got a developer, he told me, and then I don't want to put a name, he said, Why you put 2 electrical rooms? 1 room is enough. I can make another room make more money. A few years later, he come back. No one rent my building. Why? Because the banker never rent a building with 1 electrical room. You have no electrical to riser, it's no reliability.
Risk management.
Yeah.
We told you already. So now in Shanghai, we got a very famous building, collect very high rental. And now this building is about 10 years old, very high rent in Shanghai. But now it's totally completely retrofit the building because your competitors. So it's better lift, better air conditioning, better power, better data. So you don't change. But the thing is, your building is totally occupied. Can you change your building without kick your tenant out? So if you're a good developer, you're a bright developer, you're a bright architect, you're a bright consultant, can you make the building collecting money every day and keep your service changing every day as well? If you can do it, you make a lot of money.
I think one of Jose's concerns was the limitation based on evacuation considerations. Does anyone here want to comment on that?
Hello, testing. My name is Jim Fortune. I've worked with Adrian on elevator design in Burj Khalifa and now the Kingdom Tower.
I think we have the right man.
You got the right guy. First of all, I want to correct a few things you said about the speeds of elevators. The world's fastest elevators right now are in Taipei 101, 16.7 meters per second up. And the interesting thing about all these high towers, including the new ones, is the down speed is limited. So it's just like getting in an airplane. When you get in an airplane, you can take off and go as fast as you want ascending, but coming down, we limit it to about 10 meters per second because you'll get ear block. As far as the ride quality on the elevators, these high-speed elevators, they have better ride quality than any other elevators in the world. Most of them are running Burj Khalifa, the 2 observatory towers. The ride quality is less than 8 milligauges, which you can hardly feel. So they do extreme measures to do that. But the most important thing about the evacuation in the high-rise super talls and mega talls is we're actually using the elevators now to evacuate the people. So the Chinese were great coming up with area of refuge spaces. And after 9/11, I would submit to you that if something happens in a building, nobody wants to go to an area of refuge and wait. They want to get the heck out of the building. And the only way to get them out of a 100-story plus building is to ride on the elevators. So we're actually using what we call lifeboat operation. It was first used on Burj Khalifa. So people go to the area of refuge, and then we set the elevators up on attendant service so that they go to the area of refuge, pick the people up, and bring them back down express to the ground floor and make those trips. And actually, we can evacuate most of these buildings in less than 60 minutes, very easily using the elevators. So that's the state of the art in elevator design. Thank you.
Well, thank you very much for your learned answer. Thank you. We have another question right up here. Can we get this gentleman a microphone, please?
Maybe this question could be addressed to Tony Long. I'm Jun Palafox from Palafox, Makati, Metro Manila. The profit motivation is still the strongest motivation to go higher. In my part of the world, people are, at least Makati and Fort Bonifacio, they're now selling air rights, or every time you increase your floor area ratio by 1, the accommodation value, I think CBR used that vocabulary, accommodation value, the land value appreciation is about $700 per square meter on your land. And you pay only something like $50 like an impact fee, development charge. And the challenge now is infrastructure like transportation cannot cope with it. And would that be a trend as part of the world? Selling air rights, getting away with more plot ratios and so on. And you get a land value appreciation every time you increase your plot ratio or floor area ratio.
Well, I can only comment on that phenomenon in the U.S. And in the U.S., the limitation on the height of the buildings has been really driven by the cost of land number one, and number two, by the difficulty of getting entitlements. And so you saw in the growth in rents, San Francisco was really, other than New York, it was the only US city that showed really high rental appreciation. And it's because of those two things. It's because of the cost of land and the limitation of land and the difficulty in getting the entitlements to build as high as you want to build. Because in many places, there's that limitation on the floor area ratio that you can build, and you can't go beyond that. So it seems to be much more of a trend in Asia than it is, say, in the United States or in Europe, in terms of allowing the entitlements to let you go much further. I don't know if you guys have seen anything like that as well.
Thank you.
Thank you for your question. Don't be shy. Anyone else? Gentleman here.
I think.
Please identify yourself.
Peng Bing from Singapore, architect. I think when I think about super tall buildings, and I think about Corbu's proposal for like 1 million people living in a tower. I mean, let's say we were to think in terms of the number of people using a single monolith, and even if we think about it, like 1 kilometer, if it's 1 million people living within that, then actually it does eliminate a lot of the sort of the infrastructural needs that a city normally rely on, like ground, roads and transportation, if everyone was to live vertically. And if we were to remove the limit of fire evacuation and such things with, I suppose, multiple grounds and evacuation lane, I think if we push our imagination to that level, then we could say, multiply that a few times and link that all up, and we would really have a very, very compact occupation on the land required. And at that moment, I think all our cities can really shrink, and human beings can then start to live really sort of close together. In a sense, rather than having cities that are sprawling continuously, cities start to become more and more like points on the earth. Mm-hmm. And then at that time, I think our energy consumption with regards to the infrastructure or the energy requirements for infrastructure also start to become really tiny. So in that scenario, I think some of the limitations that we talk about maybe start to transform itself. The way I see MEP working, you start to think about different grounds, different ways that you generate. It's an entirely new paradigm. Mm-hmm. So even as we look at all of these towers, if we imagine that they were all somehow linked together, they could hold a lot of, and the entire human population might, be able to really fit into a tiny little space. And at that time, we have vegetations throughout the whole earth. So what might keep us on the ground? I think that might be the answer, the question. Why is everyone so, caught up with trying to live on the ground? And if we could answer that, then we could answer why not live up there.
It's an interesting point, because it's a point in favor of density, which I think is essentially. But then density calculated or really appreciated as a precondition for whatever entropy is produced in the level of social life is usually connected to the use of in the ground. And that's probably one of the subjects which translated technically is how do you achieve points of encounter in some mechanism which isn't an elevator. You could argue the subway is a horizontal elevator. But still the presence of the ground has this amazing value of distribution which is where the ability of that enormous concentration of people take place as a generator of events and so on, which doesn't mean that it could not occur like this. I'm 100% with you on that. I think the second point is you're an architect, right? So that's because I made exactly the same point this morning when I walk into this place. The problem with these objects is that they haven't reached the point yet to establish a different kind of urbanism in which they do relate to each other. Because are like independent individuals, isolated, all of them together without a sense of collective purpose, which will be the bridge essentially, or the bridges, or some other level through which the matrix, rather than being vertical columns relating on a single horizontal plane, is more a three-dimensional grid. And that's an experiment that I think most of these sort of emerging communities and emerging economies, rather, that are so powerful and so concentrated in decision-making processes would have to try. You sent me to this interview this afternoon.
I didn't send
yes,
you. The
sent me to
council
this
sent you.
interview.
I just showed you the directions.
And I thought this person asked me a question about, I've been coming to this town since 1981. And I've seen it change. And as somebody was describing today, in a completely rhapsodic way over the last maybe 9 or 10 years or more than that. The one thing that is remarkable in this place is the discrepancy between the level of quality of the construction of commercial space and housing. Housing is a market that is totally left out, probably for unexplainable reason, although not laudable. But it is that subject what is missing in this typology of buildings, the fact that it is not a multi-use, inherently a multi-use structure. And I don't know any better explanation or image or imagery for that the work in the 60s of the metabolists, which were the only ones that really understood the possibility of creating a different level of platform for the density to occur. If these things were connected, all these issues of transportation, decanting of the building and peak hours, as well as multi-purpose use would become solved by implication, I mean, essentially. So what I think is important is that perhaps we as architects would have to recover some of that thinking and bring it back into some form of regulation where the buildings are not just claiming a protagonical role in the city, but creating a three-dimensional grid.
I want to ask a related question, getting back to your point about everything becoming vertical. Do you think some of that, in some areas where we're having clusters of high-rise buildings, is already happening, and that when you go down to the street, it's not all that pedestrian friendly, just figuring out how to get around these buildings? So many of these buildings, it seems that they're designed for the automobile. How do you get in and out with the automobile? There aren't even sidewalks some places that there should be sidewalks. Do you think some of that's happening here in Shanghai? I know it's very much like that in Jakarta. It's almost impossible to walk someplace, but that's a cultural thing there, because it's considered like it's beneath you to walk. You should drive. So I would ask that question to you or Raphael or any other architect who would want to comment on that. he said it's being addressed in Saudi Arabia.
Maybe the designers are here, or planners. The King Abdallah Financial District, several levels of main floors. You have the main street level, you have the interconnected walkways, upper level, so you practically have another main floor, then another level, interconnected monorails. So they practically will have 3 levels of access to the buildings. Then comment to your comment a while ago. I was in the Harvard Graduate School of Design in year 2000, and somebody said that if we use the density of Hong Kong, all the world's 7 billion population, we can all fit in the state of Texas.
It's big. It's big.
I would love that.
And empty.
And another one was the urban sprawl. Yeah, big houses in the middle of the cities have larger environmental footprint because they are preventing more families to live closer to their places of work. They're encouraging more urban sprawl to encroach into the forest and the farms. That was the American Planning Association in Boston, 1998. So they're now calling large homes in the middle of the cities as monster homes.
But doesn't that presuppose, though, that everyone's going to the office? I think, yeah, the one thing I've learned in looking at office buildings is that people don't necessarily go to a spot to work. In fact, across CBRE, in our Amsterdam office, for example, 90% of the workspace that we have in our office in Amsterdam is unassigned. Even the managing director of our office there, his space is unassigned. And so work is changing, and people aren't necessarily working at a spot anymore. And I think that is also changing the whole dynamics of how buildings get designed, how transportation is coming about, and it brings on a whole different set of rules to design by.
Sorry, no, go ahead. Sorry.
I think as Rafael was talking, I was also thinking about, we actually do give up quite a bit of rights, like personal rights. Living in a high-rise, we almost need to conform to what the building skin might be or the facade might be. For example, in Singapore, we are not allowed to hang our laundry outside or something. you have to do it in a fixed place, and you can't add a canopy or something. And when people live on the ground, they tend to feel the freedom to do to their house whatever. Maybe I think a limitation for us is how much can human beings conform without getting oppressed and stressed out and all that. I think that's certainly from a social dimension.
I think you're diminishing the value of your very same point. The problem is that when you really look at these things, there are 3 components on the program chart. It's either a hotel, an office building, or a residential component, high-end, right? The city, once you translate it into that sort of superstructure, megastructure is an idea that is around since the 60s too, is the fact that in these structures there should be also other institutions working. I mean, in the spaces for science, the only thing you need to achieve is interrelationship between people working. It is a completely different kind of demand and would change the shape of these structures dramatically if somebody had the guts to put together something which is a little bit more ambitious than just simply an office building with a hotel at the top. And I don't know, it'd be interesting to see out of this collection which of these buildings has anything other than these 2 things, and a convention center in the base, which could be placed somewhere else too. Right? It's the ability to get public programs in elevation where I think is the game changer. And some of them are incredibly profitable. This is for the developer side. If you look at the new campus in University of California, San Francisco, it's developed as a business proposition and making a pile of money and feeding, 16,000 principal investigators' positions. And it's just, so there is I think the construction, the basic driver for construction is the development process, which is primarily executed either by the public client or by the private client. Private clients, in my mind, have a great deal more imagination than the public, but yet quite limited.
Well, I know we have seen, there are projects out there where there is a mixed use with residential included also, but maybe not as much as there should be. I want to see if we have some more questions now, and I'm looking towards the back because there's a tendency to pick people in the front because I can see them. Yeah. And any other questions? Yes. Okay, please. Yeah. And if anyone else has a question, don't be afraid to raise your hand ahead of time, and I appreciate the people with the mics to get a mic over to them ahead of time.
Yes,
okay?
my name is Peyman Nejad from Ted Jacob Engineering. I have a question. We talk about how tall or why we should go tall or not. So my question is, what is the most important limitation factor as your point of view? Is it, for example, fire, or is it human comfort? What is the limitation factor for designers, which, you know, obviously limit our hands to design taller or taller? As a structural engineer, of course, for me, is challenging, you know, to go higher. But from your point of view, what is the limitation, the most important factor, that limitation?
So you're looking for the thing that's on the edge now that's keeping us from going higher than maybe.
No,
we
the
could.
factor, I mean, from the fire or from human comfort or the other aspect of the design, we look at it when we design a tall building.
Money. So it all comes down to economic value? Anyone else want to comment on that?
You can't, unfortunately. Be great, no?
Can we get a microphone over there to Gordon Smith?
I think one of the limitations is the actual size of the building, how much square footage you're building, and how quickly you could market that space. And it does get down to money at the end of the day, and quite often it has a lot to do with how long it takes to build these buildings. You've got your money tied up for a longer period of time. The bigger, the taller the buildings are, the tougher they are to finance, the tougher they are to afford, the longer a period of time it takes to break into a profit mode.
So wouldn't you be happy if somebody would call you tomorrow and tell me, just beat that thing and don't worry about who goes inside? Wouldn't that be great?
They already have.
There you go. If they did,
Just
that's
kidding.
a good change. And therefore, the council should change its name.
There we go.
I was just kidding.
Thank you, Gordon. We have another gentleman here.
So Jeffrey Heller from Heller Manis Architects. We're in San Francisco, which you've talked about a bit, and Shanghai. I wanted to comment on some of the discussion before, you know, this idea, the ideal of cities with only tall buildings in the very center and concentrating to open up the land. It's been touched on, but I think that the thing you must accept is that there is economic distribution in the world. And economic distribution will always create a situation where you have low-rise and some sprawl in combination with high-rise. And in fact, the high-rise urban centers are the result of an intensification of very large areas of human habitation. And that will always include people who you know, are on the lower end of the economic scale, and they're not going to be able to afford, nor is a state going to be able to afford putting them into one. So that combination will always exist. In the most extreme case, you go to Mumbai and you see the world's most expensive property and the world's cheapest property in combination. So that's one thing. And then the other comment I wanted to make is the comment about the interconnectivity of these tall buildings, I think Raphael was talking about, is one of the most important pieces of what we have to be responsible for. And talking about, you know, connections of walkways and trams and so on at multiple levels still doesn't do it. It removes the humanism from the equation. And although I love these wonderful buildings, getting around here is a nightmare because it's auto-dominant. And it is the removing of the auto-dominant feature which is the thing we've been working on the hardest. I would suggest that you visit in Guangzhou the new North Axis area where actually Wilkerson's going to talk about their tower, but it's in an area where we were master planning and many others contributing, and it's all high rises, and it's basically in a park. It's a little bit like a small central park with 80, 70, 60-story high rises in it, and so it's totally walkable. There's a giant water feature through the middle of it, and it sits on top of metro and parking and infrastructure and retail and so on. And what it does is it submerges the auto and makes it people dominant, not auto dominant. And so moving around in this whole little city within a city is completely human, and that's the answer to all of these urban centers with super high rises, is that you establish a new ground plane, and that ground plane is for people and for greenery, and then we get to where we really want to get to. And I also, we work on, and I completely agree with the point about multi-use buildings and multi-use complexes, which contain, you know, not only office and retail and hotel, but also housing, cultural facilities, and everything else, so that it is really a livable community at one time.
Thank you very much for your comment. Your point about auto dominance just reminds me of a quick story somebody told me recently about the alien passing by in a spaceship looking down on Earth, and they asked the alien, "What did you observe from out in space?" He says, "Well, Earth is a planet inhabited by automobiles. They get people to take them anywhere they want to go." I'm sorry, Raphael?
No, if they...
Why don't we see, any other questions?
I
Yes.
just wanted to
Rene?
answer you later. Go ahead, please.
Can we get a...
Thank you. My name is Rene Lagos. I'm a structural engineer from Chile. Chile is a seismic country, and my question is as follows. There's a difference between seismic design and wind design. Usually structural engineers are concerned with the perception of motion for wind design. But when you think of seismic design, structural engineers are concerned with non-structural damage or structural damage, but no one cares about what the perception is of the people living in high-rise buildings. From my experience, when you live through an earthquake, the feeling that you have is the building starts moving, start overturning, and it's never coming back. When my experience has been on 3-second period buildings. Right now we have 6 and 7 second period building. So people get so scared, they don't want to go up back in the building after the earthquake. And the experience that we had in Chile 2 years ago is that after the earthquake, with so many aftershocks, not only people didn't want to go back, but the properties in the upper floors lose their value. And developers, for some time, they stop designing high-rise buildings. Of course, after 2 years, the experience is that people tend to forget about it, and they all went back. But I think it should be an issue, maybe, to design for a certain perception of motion I would like to know your opinion on that.
Well, first let me say, we didn't spend too much time on seismic, but if you saw in my last slide, it was one of the considerations. And the reason for that is, as you get very tall, flexible buildings, usually wind is governing the design more than seismic, although seismic is still extremely important, taking care of the ductility of the building and the connections in the building and things related to that. But I would tend to agree that there is a tendency in our industry that we pay attention to the comfort of people in the building for wind, okay? And in these very, very tall buildings, okay, like I showed you one there before, which did not get built, but Calatrava's spire. The problems we had there, it wasn't a problem, but the motion that we were concerned about was for the 1-year return wind. We had higher accelerations on that than we had on the 10-year wind. And you'll find that's not so uncommon on these very, very tall, high period buildings. And we fuss all about that, making sure that people will be comfortable in that. And I think it comes from the fact that we still think in most of the world, maybe not in Chile, I've been to Chile, as I know, it's when I had the pleasure of meeting you, but in most of the world, people think in terms of an earthquake as of something that doesn't occur that often, and they're primarily concerned with safety, getting people out, but they're not thinking in terms of people hanging around during the earthquake. So I personally think it's a mentality. I mean, that said, as many of you know, there are restrictions in the code as to how much sway you could have during an earthquake and other things like that. And we worry about the amount of dampening in the building during an earthquake. But I would agree with you that there isn't as much emphasis on keeping people comfortable. In fact, there's probably no emphasis in our standards on keeping people comfortable during an earthquake as there is on keeping people comfortable during a windstorm. Any other questions? Okay, I got the 10-minute sign there coming up on us, which is probably down to 7 minutes now. I'd just like to ask the panel if there's anything else anyone wants to say in summary.
Not in summary. I wanted to ask you if there are advances in seismic design for very tall buildings that are relatively new and unheard of, like this gentleman commented on the elevators. I mean, is a tall building less safe than a low-rise building?
No, I wouldn't say it's less. I worry more about a low-rise, very stiff, non-ductile building than I do
about something that is flexible.
Tall building, okay? But on very tall buildings, you still have to be very much concerned on the overall performance of the building, the failure mechanisms of the building, making sure if there is any damage from an earthquake, it's in a beam, not in a column, things of that nature. Okay? And there's been a lot of advances in the seismic industry, if I can use that term, relative to damping procedures and relative to slides under the buildings and things like that that can relieve the effects of an earthquake. Anyone else want to make a closing comment? Well, when we originally put this together, I thought I was going to make a little summary of everybody's comments. The only thing everybody seemed to be in agreement with, I'm sorry, Tony, is to change the name of the council.
Yes.
Okay. It's the only thing that came up more than two or three times. I think the other agreement here is that we structural engineers are off the hook. Okay, we're not limiting anything. Okay.
Sure.
We'll take you to a mile and beyond. Okay, that technology's here now, and it will probably go even higher than that as we get into new inventions and in our area and even stronger and stiffer materials. And I say stronger and stiffer because, like with concrete, for example, it gets stiffer as you make it stronger. So I think many of the issues may lie in the area of the other technologies and the economics, and I still believe that there are sociological issues based on people's preferences as to where they want to work or where they want to live. So with that, I'd like to thank Tony, Raphael, and Vincent for your wonderful presentations, and I want to thank the audience for their participation. Can I get a motion to adjourn? Thank you.